fascinating because if you don't know which one's bigger, it's not going to help.
Yes.
I was going to say that.
Alligator, well, eats the bigger one. Yeah, it eats the bigger one. So, yeah, the bee is bigger, so the alligator's eating the bee. That never worked for me, but it works for some of them. Yeah. Just however your mind processes stuff. All right, so for this first one, the value of b is 3 over 2. Now remember, b cannot be negative. So our b for this next problem is just the positive 3. What would be b for the next problem?
2/3.
Yeah, 2/3. Fill out b for the next two, for 4 and 5. Okay. Lucy, what'd you get for number 4? Yep. For number 4, it's 2/3 again, because that's the number it's raised to the power. And Candy, what about 5? Yep. Again, that's the number that's being raised to the power. Now, the reason why it's important to figure out b is it's going to help us figure out whether it's an equation, an exponential that rises, that increases, or decays, or decreases. All right, back to a. A is the number in front of that, so in front of b. So in this one, there's not one that's listed there, so it's an understood. I heard somebody saying it. Yeah, it was crazy. It's just a 1. What about number 2? Negative 1. Because b was 3, but that's because b couldn't be negative. So it's a negative 1 that would be our a. See if you can figure out a for 3, 4, and 5.
Is it raining? Do you see rain? Oh, I see the wall.
No, it's not raining.
You would still see rain because there's not a roof over that area.
Well, you don't know that.
Yes, I do. I can see the sun. That's how I know that.
Okay, well, let's see. Jacob, number 3, what's A? 2. Gracie, number 4, what's A?
-1.
And Kimberly on 5. Negative. Questions on how to pick out A or B? Honestly, I'm not even going to worry about C. I don't need that right now.
Is it like, would the first one be 2?
Yeah, it would be 2 because it would be negative x plus 2 equals 0. So I would add x to both sides. So that's our C. Yeah, it's weird. But honestly, it'll help us a little when we go to graph, but not enough to worry about it. Okay, then skipping to D. D is whatever, if anything, is added or subtracted. So for number 1, it's obviously -2. If there wasn't a number there, see, I scribbled that out on number 2, what would D be?
1.
0. The reason why it's 0 is because it's plus something. If it was times something, it'd be a 1. But yeah, it would be 0 if there's not one there. So fill out D for 2 through 5. All right. So for D, Emily, what about number 2?
Yep.
Number 3, Ashton.
-2.
You got it. Jaden, number 4.
3.
Yep. And number 5, Sophie.
-1.
Yep. Questions on how to find A, B, or D? The last part, we're going to use the equation to help us figure out if they have reflections. Reflections we learned way back in the day. Way back in the day. Say we had this parabola, y equals x squared. What could I do to that equation to make it point down instead of up? Yeah, I could put a negative out in front of the entire value there. It would look like this. So
So
really,
pretty much just switching the sign of the original equation.
yes. So you're putting a negative, it looks like it's in front of x, but it's really in front of y because it's the whole thing. It's the entire equation. So when you do that, that is going to flip-flop across the x-axis. So, for example, if we had y equals 5 to the x, it might look something like this. If I tried to make it y equals -5 to the x, then it looks like that. It's been flipped. Oh, that looks really bad. Try it again. It would be flipped up and down across the x-axis. And then, if we had something like this, y equals x cubed, we learned back in the day. It looks something like that.
I definitely forgot all of those.
That's okay.
Yeah.
If we flip-flopped it and put the negative just in front, yeah, just in front of the x. Actually, it's going to look the same either way, but go with me on this. It would flip it across the y-axis. So it flips it across the y-axis, across that. And so that's just by making what's inside there negative. So how we make this look with exponentials is if we had, again, say 5 to the x. Say it looks like that. If I had 5 to the negative x, then it'll make it like that. So it flips across the y-axis. All that to say, notice this first problem. Gracie, notice this first problem. It's not on your phone, promise.
That's where it is.
We have a negative in front of the x. So that means it flips across the y-axis. So the type of reflection that it is across the y-axis. And that's because there's a negative in front of the x. What's another one that has a negative in front of the x?
Number 4.
Number 4 does. So I know on number 4 it's also going to have to flip across the y-axis. Okay. So far so good. have a negative out in front of the entire exponential, like on number 2. We have that negative right there. So if B is negative, not B, A is negative, then it's going to flip across the x-axis.
Number 4 has it.
You're right. So the other one she said is number 4. So on 3 and 4, it's both of them. It has flip across the x-axis and the y-axis. What's another one? Number 5. Number 5 has this x right here in front of the b. So it also flips across the x-axis. So number 3 actually doesn't have either one of those. It doesn't reflect. On the back of this page, on page 410, we're going to look at these graphs and tell, if we read them from left to right, whether they're growth, which means they increase, or whether they're decay, which means they decrease. I'll help you with the first 2.
Growth.
Yeah. Notice we're going from, left to right, so we're going up. When I read that equation, oops. There we go. So this is growth. And then number 2 then would be decay because it goes from the top to the bottom. It's lowering, it's decreasing. So label all those. I guess 3 through 12 is left. And we just put a D or a G. Yes. Yes. Grab task. Leave door crack, which already is. Cindy, are you hot? What? Was that what she said?